And our next talk today is online from Lukasz Wyrzykowski. I'm very sorry.
Well done. Yeah, very good.
Who will be talking to us about using a network of small telescopes to follow up on transients. Thank you.
Okay. Hello, everyone. Just to confirm if you can hear me well.
We can't hear you.
Okay. Good. So thank you for this opportunity, and I'm sorry I can't be there with you, but I hope we can still. I can still transmit some of the messages here, and thank you for letting me this opportunity to speak. So I'm Lukasz Wyrzykowski, and you've done very well with pronouncing my difficult name, and I'm co-leading work package 4 in ACME on the archives, but I'm also involved in work package 5. On the alerts and their follow-up. So I'm going to talk to you about the BHTOM, one of the infrastructures we have in ACME, which is in the domain of optical astronomy, time domain astronomy in particular. Okay, just a couple of faces to show. This is a project which started at the University of Warsaw, and now with ACME it's funded through National Center for Nuclear Research. Apart from myself, there's a couple of people involved on that side, and just recently we started. We're about to hire new people whose names are already listed there. So we're expanding slowly but steadily. But the group is generally small, and there is also a bunch of students and international partners involved. Okay, I'll try to run an animation here. I hope you'll be able to see it. So this is an animation of the transients found in optical by the Gaia space mission. So Gaia has just stopped observing, unfortunately, but this is the mission which has been scanning the whole sky for 11 years, and the alerts reported by Gaia were made public essentially as soon as possible within the dedicated pipeline which was run at the University of Cambridge. So this is something what we call Gaia Science Alerts, and I've been involved in that. And the main thing you see here is that Gaia is the whole sky, was the whole sky mission, and you see the alerts. Which by alert I mean something what is changing on the sky, appearance of new sources, changes, unexpected changes in other objects, decreases of brightness, increases of brightness, whatever astrophysical phenomena we can think of which are unusual and worth knowing about immediately. This is the whole sky, all parts of the sky, including the both hemispheres, and then all the galactic centers. So this is a completely unbiased survey. But in order to make use of these alerts, we've established already back in 2013 the network to support these alerts. So what's the point of alerting if there is no one picking them up, especially that they came from all possible sorts of astrophysical phenomena, spanning from classical transients like supernovae, TDEs, and so on, to outbursts in quasars, but also changes in variable stars and so on. So far, we've built a network of about 130 telescopes. They are scattered all around the globe, of course, because we've been monitoring the whole sky. And the sizes of these telescopes, they come from all the way from 25 centimeters to 2.5 meters. Some of them are manually operated, some of them are robotic, some of them are with good weather, some of them are with poor weather, and many of them were just providing their observing time voluntarily, and for some of them we had to write proposals. Generally, this is the overview of these within Europe. You see that there is plenty of telescopes where conditions are not perfect. However, because there is plenty of these telescopes just lying there and sometimes having nothing to do, so that's why we managed to involve these telescopes and use the time they had essentially as on voluntary basis. Whenever they could provide some observations. So what are these small telescopes we've gathered? So some of them are professional. of course, and some of them are very, very old. And there are also, of course, new ones. They're built in best astronomical sites in the world, but the old ones, of course, they are located in not so great parts weather-wise. But there is also a growing number of amateur observatories. So they are modern, they're growing in numbers. They're often located in backyards, sheds, but sometimes they're also located in Chile or Spain, good observational sites. Moreover, schools these days, they are getting equipped with very decent equipment and telescopes. And these telescopes, the same applies to outreach facilities. They're typically located in cities, maybe villages, small towns. The conditions are not perfect. However, there is more and more of these. And very often these telescopes are used typically during the evening to show the kids how the moon looks like, and M31 again. However, then they remain, they can be employed to do some science after the hours, let's say during the night. So gathering all this, we've built a tool which has expanded. Now we call it Black Hole Target and Observation Manager. The name here is taken from the TOM toolkit, what Fabian mentioned. And this is the open source code designed by LCO, Las Cumbres Observatory, who were actually, they are the pioneers in establishing networks of telescopes. So we were able to take the software and also rely on a lot of help from LCO in order to build this. But we've expanded this tool to with additional features, especially to work on a very heterogeneous network of telescopes, and also to expand its features. So essentially, this is a web tool for coordination for time domain observations. So it has the automated observation requests. This is something what was built in all TOM toolkits. But the thing we've added to this is processing of raw images, raw data from these heterogeneous units. And also on top of that, we do the automated standardization of the data. As well, we query the archival multi-wavelength time domain photometry, all the data which is available there. And of course, we're open to for new telescopes, new users, and new targets. So you see a couple of screenshots here. Of course, I have to mention that we've expanded away from Gaia, especially now with Gaia being gone. So this is my version of the chart Fabian showed in his review just a moment ago. This is just to show you where we fit with BHTOM. So we have the surveys which are scanning for transients in general, essentially anything what generates alerts. So apart from Gaia, there's also gravitational waves. You can think of multi-messenger environment here, and these are then handled by brokers, and that's another chapter of work. And this is great work being done by many people. But in the end, there is some end user which decides, okay, these are my science case interests, so I'm interested in that particular type of event. So I will weed them out of this flow and flood of all the alerts coming. And I would like to have them observed. So, for example, someone has identified 10 candidates for gravitational wave counterparts, or someone is interested in that particular event found by Gaia and requires 1 year of observations. So this is where we fit in this. So there is the observing requests can be sent to BHTOM, and this is where the role of the involvement of the user essentially ends, because we then handle all the communication with the network of the telescopes. So you see, we are like a proxy between the users and astronomers and the network of telescopes. So you don't have to write any proposals. You don't have to make sure this target is visible through in that part of the sky or not. It is all handled by our tool. So the request is being sent to the network of telescopes, and the network responds, and then the network generates the observations. And again, this goes back to us, not to the astronomer or scientist interested in that particular target. Moreover, we query all the archives for that particular coordinate, and we extract whatever is there, whatever has been observed so far. It might partially answer Susanna's question here, because if the target was observed at least in this part, in optical parts, then it has any observations already collected by various surveys. We already extract that, and it will be there available by a simple query by the transient name. And then what we generate in the end is the science-ready data products, and this is what is returned to the user, and then the user can focus on studying the data and writing a publication. Everything what I described here can be scripted. So all the flow, so you can replace the humans in the loop with the bots. So all the extraction of the interesting alerts and targets from brokers can be automatized. Then the observing requests can be automatized. The processing within our system is also automatized in case of robotic telescopes, and there is always a human in case of manual observatories. However, anyway, the data then can be returned to you again in an automated way, and then you can ask your robot to write your paper if you're brave enough. So, as I said, the main feature we've added is we take care of probably the main bottleneck at least in the optical observations and follow-up, is that we automatically process the data. So far, at this moment we process something like 10,000 images every week from this network of various telescopes. And then we do the standardization of these observations, and we use Gaia synthetic photometry as the standard for the whole sky. And then the data is downloadable and is essentially science ready. Everyone who's registered can access the data collected. So here you see a couple of example images from various telescopes for different targets. Well, as I said, everything is scriptable. So we have API. So essentially, you don't need to enter our web page at all. Everything can be scripted, and we provide example scripts for that. So the data flow to and from telescopes is automatized. If you're on the telescope side, then the observing requests can also be automatized. The target creation, upload of the images. So this is something what AstroColibri has already implemented. And so essentially, users of AstroColibri can just, with one click of a button, they can send their target of interest to BHTOM, and then it's being observed for them, and the data can be then transmitted back to AstroColibri. And as I said, we provide the ready scripts for all these. Just to show a couple of examples of science cases. So the top one is an AGN where you see a light curve, AGN, which someone is interested in having a long-term follow-up. So there is various data sources. Here you can see. I'll get to that in a second. What else can you get there? There is another example of the famous supernova 2023 IXF. So here we have data essentially from X-rays, UV, all the way to infrared. You see, well calibrated, essentially science-ready data for download. Another example is a planetary microlensing event we followed. So you see the light curve of a microlensing event with a tiny blip, which is due to a planet, which was found thanks to the intensive follow-up for many, many months. That's one advantage I would like to raise here, is that not only we can respond fairly quickly to the alerts, the other advantage is that we can stay on the target for many, many months, and you don't need to write any proposals for that, right? So if your target is going to last long, then we can provide the data for you. There is some other examples. There is an eruptive variable which is varying very quickly. So we have very short cadence observations, and you can decide what cadence you request for that particular target, how often you want this object to be observed. There is another supernova in another crazy microlensing event we observed. Speaking about the archives, I would like to emphasize that there is a hidden treasure in time domain archives these days. Apart from obvious ones like ZTF or Gaia, there's also a wealth of publicly available old optical observations, for example, CRTS, linear, even PTF, even SDSS has some time domain data which you can access in optical, then NeoWise in infrared, and there's also a growing number of available time domain radio and X-ray data sources. So we query all these archives for you, so you don't have to even be aware of all of these. Whatever is available at that position, we can get it out for you. So that could potentially be extremely useful if you're looking for, if you're studying a transient. You can very quickly rule out some transients which, for example, they're cataclysmic variables, right? So we know that they repeat and they are not cataloged anywhere. In the archival data, you can immediately see that this object has been flaring on and off over last decades. And speaking of long time scale of data, here you only see 25 years of data, but recently we've implemented even longer data set. So you can, for some of the targets, you can actually now use, you can have the data spanning, starting from 1880s. So this is what the DASH catalog offers. So these are the Harvard photographic plates, which has been scanned laboriously. And here you see an example of the recurrent nova T Corona Borealis. We're all waiting to explode. And this is the outburst from 1946, which you can see. And if you have any other ideas what could be added and what we are not aware of, I'm very happy to talk about this, especially spanning to other means and other wavelengths like X-ray or even polarimetry. We can implement it and make it available to people. There are of course publications being produced by our users. And the data policy here we have is that all the observers are invited to co-author the papers, which very often is making these people very, very happy. As I said, some of them are amateurs or school observatories. We've had an example of a British public school who contributed very nicely to one of our observations, and they've ended up as co-authors of a paper. So you can imagine how happy these pupils were to be included in the publication. But generally, this is the policy we have, and the data is available for all the users. But also, just to keep it, to answer some questions coming here, we keep track who is downloading and who is using which data, and of course we do have a lot of trust to people. But if there is a need to make some data private, we can also do that. Coming towards the end, I would like to advertise a new initiative we started actually, which is related to BHTOM. We've established a foundation which is called EASST, like the East, but it's for the name stands for European Astronomical Society of Small Telescopes. So we realize that there is a huge potential of citizen science these days, and BHTOM is a great tool to have this to help also amateurs and other people who are not professionals to contribute to science. So that's why we established this foundation, which is trying to facilitate that. And we are planning on having outreach activities, local and global. We hope to connect astronomers, professional and amateurs, but also we hope to expand the telescope network we already have for both science and also outreach, as well as space industry. Also, we are planning on enhancing the telescope technology to optimize the use of the small telescopes, especially the ones with poorer weather conditions. Another aspect of the foundation is that protecting dark skies is a growing issue, and which actually affects the science and not only science. So this is something what we also have in mind here. This is a picture of people establishing the foundation, and I'm happy to talk more about this if people are interested in becoming partners. Lastly, I will talk about some workshops we've been having. As I said, we started running this telescope network around Gaia, especially Gaia Alerts. So we've been running essentially every year. We've had a workshop starting in 2010 in Cambridge, workshops where we could gather the users of the telescope network, but also people interested in transients and time domain astronomy, and it has evolved over time. It's still related somewhat to Gaia, but it also has expanded to other domains. And we're having one this year, and it's going to be within ACME time domain framework this time. So in late September, early October, in La Laguna on Tenerife, we'll have another workshop, and the registration has just opened. So I strongly encourage you to take a look and come and attend this. So to summarize, Black Hole TOM is a global network of optical telescopes for time domain observations in optical primarily. However, as I said, we have access to many optical and radio time domain archives, and we plan to expand to further domains. And it provides long-term multi-wavelength photometry of your targets. And by meaning long time, I mean we're talking years. Some of our targets has been followed consequently over many years now. In order to make it usable for future, we plan to coordinate the LSST in-kind follow-up resources. This is the idea we are exploring. We plan to expand on, of course, within ACME to multi-messenger targets. We also would like to expand to solar system objects, which is another domain of observations small telescopes can contribute to. And of course, expanding on the archives. And if you have any more ideas, I'm all ears, and so get in touch. So thank you very much. I'll stop here.
Thank you very much, Lukasz, for that very interesting talk. Questions from the audience?
Hey, so I have a question on the reduction of the data, because you said that you reduce 10,000 image. So how you do, because it's very heterogeneous. So people, do you with astrometry, or you do it by yourself from the start?
Yeah, well, we start from, well, you can upload a raw image with no astrometry in it, with in any kind of filter you have. We even process the RGB amateur cameras, and so over years we have developed a software which is essentially using the old school Sextractor, DoFOT, and all things like this. But this is so we've wrapped it up in our pipeline, and now we can process, I would say, more than 90% of images. They get processed successfully, and I think we are comparable to whatever people can get themselves. But the main thing is that we can do it for any telescope. That's how flexible this pipeline is.
Any further questions? In which case, I had a question about how, well, you said it's not proposals that are submitted, but how are proposals or requests for observations prioritized by your system?
Mm-hmm. Well, it's a very valid point. At the moment, we don't have that many targets. Well, I would say we have something like 300 targets which are now of interest, and we prioritize them depending on the urgency, depending on how urgent the target is. It depends on the class, of course. And then also the visibility is an important factor here. But then also we let the observers on the telescope side often decide which targets are more suitable for them. So in that sense, people use our own criteria in the prioritization, but still they can pick, they can select. Some people prefer observing supernovae, and some people prefer observing microlensing events. And because it is all voluntary basis, we cannot force them to do that, right? But on the other hand, because we have so many telescopes, there has never been a case that we had a target which was missing observations. I realize this is going to grow into a problem if we have more of these, and I'm open to suggestions on this.
Fantastic idea. I really like it. My question is about what is the lowest magnitude target that you have observed?
Well, yeah, of course, it depends, right? Because we have a range of telescopes, but we can go down to 20 easily. But of course, there is less telescopes which are capable of reaching down to 20. I would say 20 is like a reasonable number. But some small telescopes can reach easily to 19, 18. So that's available. Yeah.
Well, thank you for the very nice talk. I was thinking about objects that may enter in outbursts, like X-ray binaries, for example, but that are mostly quiescent. Is it possible to ask for this type of objects and follow without any?
Yes, of course. This is a very nice science case. You can enter your target, which you know it will explode at some point, and you don't know when, and just ask people to keep observing it. We actually have some X-ray binaries already in the system, and people are observing them. And there is, as far as I remember, the requirement is that there is only you need an observation once a week. So these are very easy targets for us. So there's no high demand, no high pressure on the observations. And if you observe them frequently enough, then you might actually be able to. And then you can, of course, script it, and then you can see yourself if your object is already in outburst. So this is something what you would be interested in. So you can script your own alerting system within our system easily with the scripts we provide.
I think one further question from me then. In terms of creating these requests for observations with your network, how much flexibility, I suppose, is there for users, proposers to say, I'd like an observation weekly, monthly, every 2 months, is there also the possibility to request of a specific size of telescope if you're concerned about magnitude or visibility?
Yes, of course. You can specify when you create your target. You can specify the cadence you request. That's for sure. But then, if you provide the additional information, you can essentially put it in a comment that this target, please observe this with this frequency in this set of filters with telescopes no smaller than this and this. You can provide that, and people see that in the comment, and they react to that. This is not automatized yet, but if there is a need for that, we can easily put that into the system.
If there are no further questions, then I'd suggest we all thank Lukasz again.